A decade ago, the term artificial intelligence would make most of the people think about futuristic sci-fi missions or sentience or even self-aware robots. So artificial intelligence is today one of the most sought after area in education, healthcare, space sector, and in businesses, in industries across the world. As the amount the data created continues to rise globally, AI forms the crux of ongoing digital transformation happening in all of our professional and personal lives too. So once a mostly research-oriented field, AI has come out of the lab and is fueling in real-life applications. Life in more way than one. So from aiding self-driving cars, transforming healthcare sectors, and predicting legal outcomes to providing the media and shopping suggestions, and improving the video game experience and advanced space exploration, AI is playing more than a significant way and has a more driver's role in our life than ever before. So with a high demand for AI technique and implements in industries, this is going to be an opening up for new career paths, not just in AI, but also in AI adjacent fields such as computer science, math, and statistics. So what exactly is AI? Artificial intelligence is the ability of machines to mimic human capabilities in a way that we would consider smart. So how AI is different from normal computing? In conventional computing, a programmer writes a computer program and precisely instructs the computer what to do to solve a particular problem. So with AI, however, the programmer instead writes a program that allows a computer to learn to solve a problem by itself. So once the computer learns by itself, not only a single problem or not only a previously given problem, it can also be trained to solve a new kind of problem as well. So that sounds like overdoing it, but this is really the way we do things. At school, students learn the rules that allow them to solve vast number of different problems. Instead of teaching thousand solutions to 1,000 problems, teachers teach students the practices and techniques how to solve a variety of problems instead. So the idea behind AI is that we teach a computer to learn to solve problems, and because our machines are good at crunching large amount of data without even getting tired. So computers can solve some more tough problems that our brain would struggle with. So artificial intelligence is a method of making a computer controlled robot, a software to think intelligently like human mind. AI is accomplished by studying the patterns of human brain and analyzing the cognitive processes. So it is nothing but an imprint of, the AI is the imprint of human brain. So the outcome of these studies develops intelligent softwares and systems. Researchers extend the goals of AI to the following. I have mentioned four goals of AI in general. So starting on with logical reasoning. The first goal of an AI is logical reasoning. So here's a pic of a competition where AI program enables computer to perform sophisticated tasks. And then as an example in the image, it is taken on 1996, and IBM's Deep Blue computer won a game of chess against former world champion Gary Kasparov. So that's an example, and that's what the logical reasoning is all about. And the second goal is to achieve knowledge representation. So small talk is an object-oriented, dynamically typed, reflective programming language that was created to underpin the new world of computing, exemplified by computer-human symbiosis. So the third goal would be planning and navigation. So the process of enabling a computer to get from a point A to point B is an planning and navigation. A prime example of this is Google's self-driving Toyota Pyrus. So here's an image of it, and you can also Google it. Like this is first self-driving car which was created, and one of the first. And this is being widely under research and The car is built by Toyota company. And for further videos, you can check it out in the YouTube. And the fourth goal is a natural language process. It sets up computers that can understand and process languages of are much more easier. It can understand human language and transform it to a computer language. So the fifth goal is perception. So the sixth goal of AI is emergent intelligence. Intelligence that is not explicitly programmed but emerges from the rest of specific AI features. So the vision for this is a goal to have machines which exhibit emotional intelligence and moral reasoning. I'll explain this term clearly in the upcoming slides. The broad levels of AI. So as we spoke about the goals, we need to classify it into different levels of AI for better understanding and for better improvement in the AI field. So once we have break down the parts of any technology into small or classified terms, it would be easy for us to understand and we could eventually grow much more in the field. So that's the reason behind this broad levels. And it has been clearly separated into three narrow parts. I mean, three narrow levels. It is general AI, narrow AI, strong AI. The truth is that despite being surrounded by intelligence that is not biological, few of them use the term artificial intelligence in the right context. So misusing and misunderstanding the term can cause us to fallacious statements and assumptions about what the future holds for us. As we know, the world is changing at an alarming pace. So thinking critically about the current stage of technology is crucial. We want to thrive in the future. So to adapt in the world driven by change, understand the implications of AI on society and clarify whether we stand where we stand today. We need to first distinguish the various types of AI. And the three broad levels, as I mentioned here, let's start on with general AI. And general AI is nothing but an artificial intelligence that can perform cognitive tasks with same level and accuracy of human brain. So it is nothing but a replicate of an human brain. And the general AI is something which is currently we are using. And this is a bit hazy or what is a bit not intelligent level of artificial intelligence. This is the first step, so it generally starts with it. So the narrow AI is, this refers to the applications where machines can perform specific tasks better than humans. Most of the current research of AI is happening in this area. As I mentioned earlier, in the Deep Blue, IBM's Deep Blue computer, which beat the Grand Slam chess champion, former chess champion, and that's the example of narrow AI. It does or it performs something which outthrows the humans, not in a bad way, but it can perform much better than human brain as of now. So the strong AI. This level of AI enables machines to outperform the human brain in many tasks. So it is like much more intelligent than narrow AI because it can think steps ahead and many steps ahead, and it can also do certain tasks far quicker than narrow AI. It is an upgrade of narrow AI. So I'll explain every term in detail. So narrow AI, let's start on with narrow AI. So every sort of machine intelligence that surrounds us today is narrow AI. Like take for example, Google Assistant, Google Translator, Siri, and even Amazon's, what's her name again? Echo's name? Alexa, yeah, Alexa. And other natural language processing tools or examples of narrow AI. So some might assume that these tools aren't weak because of their ability to interact with us and process human language. But the reason that we call it weak AI or narrow AI is because these machines are nowhere close to having human-like intelligence. They lack self-awareness, they lack consciousness, and they don't have genuine intelligence to match the human intelligence. In other words, to be so simple, they can't think for themselves. They need a programmer or they need certain level of commanding to do certain tasks. And when we converse with Siri, for example, Siri isn't a conscious machine responding to our queries. Instead, Siri is able to do what it is designed to do, is a process of human language. It enter into the search of Google engine and returns us with the result what we asked for. So it does not think for themselves, but it is an act of pre-program. So the second one would be about the general AI. So the general AI, or we can call it as a strong AI also, it refers to missions that exhibit human intelligence. In other words, AGI can be successfully perform any intellectual task that a human being can generally do. So currently missions are able to process data faster than we do. As we human beings, we have ability to think abstractly, strategize certain tasks, and tap into our thoughts and memorize to make informed decision or come up with the creative ideas. This type of intelligence makes us superior to machines, but it's hard to define because it primarily driven by our ability to be sentient creatures. So therefore, it's something that is very difficult to replicate in machines. So AGI expects to be uh, AGI is expected to be able to reason, solve problems, make judgments under uncertainty, plan, learn, integrate prior knowledge with decision making, and be innovative, imaginative, and creative. So these are few features that we expect in an AGI. But for missions to achieve true human-like intelligence, they will need to be much more capable of experiencing consciousness. So that's the difference between us and then AGI. So next would be the artificial super intelligence. So ASI, it will surpass human intelligence in every aspects, from creativity to general wisdom to even problem solving and many other stuffs too. So missions will be able to will be capable of exhibiting intelligence that we haven't been in the brightest amongst us. So this type of AI that will many people be worried about, and the type of AI that people like Elon Musk think will lead to the extent of human race. So ASI is a hypothetical AI that does not just mimic or understand human intelligence and behavior. It also where machines become self-aware and I am once again sorry for the cause. And let me continue where I left. So super intelligence has been long a muse of dystopian science fiction in which robots overrun, overthrow, and or enslave humanity. So the concept of artificial super intelligence is AI being evolved to be an akin to human emotions and experiences. That it does not just understand them, it evokes emotions, needs, beliefs, and desires of its own. And good example is if you're from Tamil Nadu or if you're a fan of Kollywood, you would have realized what a chitty robot is. So in Indiran or in 2.0, it's 1.0 or 2.0 something. So in that movie also it is an vast example or good example of what a super AI is. So in the first part where Chitty got into a negative chip and it develops feelings and needs for its own. So that's a good example of super intelligence. So there are many movies like that. For currently, I don't have enough uh, memory to recall it, but okay, I'll try to post it up in the group. I'll refer few good movies and good books about AI and robotics soon. So in addition to replicating the multifaceted intelligence of human beings, ASI would theoretically be exceedingly better at everything we do: math, science, sport, art, medicine, hobbies, emotional relationships, everything. So ASI would have a greater memory and faster ability to process and analyze data and stimuli. Consequently, the decision making and problem solving capabilities of super intelligent would be far superior than those of human beings. So the potential of having such powerful machines at our disposal may seem appealing, but the concept itself has a multitude of unknown consequences. If self-aware super intelligent beings came to be, they would be capable of ideas like self-preservation and self-awareness. They could defend for themselves and they won't be listening to the human codes and human commands anymore. So that goes higher than being helpful needs or kind of a made robot. So it just breaks the line from being kind and nice. So that's one of the consequences. So the impact this will have on humanity, our survival and our life is purely speculation. So now let's look into the types of artificial intelligence. Actually, there are four types of artificial intelligence. So before I shared was what the broad levels of artificial intelligence. Now I'll be discussing about the types of artificial intelligence. So the starting on with purely reactive type, these machines cannot form memories. Hence, they don't have any past experience or data to work with. They specialize in performing just one specific task at a time. So for example, programmable appliances that perform specific tasks such as automatic coffee makers or washing machines fall under these categories. Another example is chess game where the machine observes the moves and makes the best possible decision to win. And once the game is over, it does not recognize or it does not recall what are the previous matches it played. And second type of artificial intelligence is limited memory. So these missions keep collecting data they encounter and add it to their memory. They rely on past experience where performing a function. However, they can only use these experiences to make decision but can't form any new ideas based on it. So this is a point which we need to note. I'll repeat it once again what limited memory type of AI is. So these type of intelligence, it experiences to make decision but cannot form new ideas based on them. Hence, they are limited in the way they utilize their memory. So some example is include self-driving car, Netflix recommendations, and restaurant suggestions. So these are few examples of limited memory type of AI. The next would be theory of mind. So these machines are closer to human brain in way that they can interpret human emotions and they have cognitive understanding based on the environment, like facial features and facial emotions and etc. So this kind of AI can understand thoughts, emotions, as well as can interact socially. So though this type of AI is not as of now practically arrived, so there is a lot of research and taking around in this area. And the fourth type of AI and the final is the self-aware. And this would be the last stage where this is a class or super intelligent or called as a self-aware missions, where which I previously we went through in the broad levels of AI. That's the last step and that's the last level. And here is it's also the same, which drives the missions to future of AI and or seen as a next gen technology. So they will be able to imitate many human reactions and will likely use internal models to simulate their actions. So self-aware missions are the future generation of new technologies. They will be intelligent, sentient, and even conscious. Okay, so let's talk about machine learning, deep learning, and artificial intelligence. Many have a wide confusion and lack of idea where the difference between machine learning, deep learning, and artificial collide. So these terms have become the most talked about technologies in today's commercial world as companies are using these innovations to build intelligent machines and applications. And although these terms are dominating business dialogues all over the world, many people have difficulty in differentiating them and understanding them. So this session will be helping you to gain a clear understanding of AI, machine learning, deep learning, and how they differ from one another. So the three terms are often used interchangeably, but they do not quite refer to the same things. Because here is an illustration designed to help us understand the fundamental differences between AI, MI, and DL. So artificial intelligence is a concept of creating smart, intelligent machine, and machine learning is a subset of artificial intelligence that helps you build AI-driven applications. And deep learning is a subset of machine learning that uses vast volumes of data and complex algorithms to train a model. So I hope now you could get a clear idea, because once you have the steps of achieving AI is that you should have a deep learning model, and then that model is being implemented in a machine learning, and that machine learning will be helping you to build a AI driven application. Because actually AI can be built using different steps and different algorithms, but deep learning and machine learning algorithms are the shortcut and the best effective way to create an AI. So as you could see here in the slide, this is a famous quote given by Mark Cuban, and I'm not sure whether you have heard about him. I eventually got to know about him through Shark Tank series. It's an English series about entrepreneurs, and if you have enough time to, and yeah, I would suggest you to watch it. So artificial intelligence, deep learning, machine learning, whatever you're going to do, if you don't understand it, learn it better, because otherwise you're going to be a dinosaur within 3 years. And this quote is a long back one, because now if you're not going to learn these terms with any background, like any kind of people can or should learn this, because artificial intelligence is being applied everywhere and it is going to dominate every domain and every field in this world. So this is not a warning, of course, this is a suggestion, because if you want to thrive in this world, you need to be updated technological wise. And the future of technology is AI, so that's it. So now let's look into each of these terms in wide. So starting on with machine learning, under the umbrella of machine learning, a variety of topics such as the different maths used to predict AI outcomes, data collection, labeling those data, resource provision to power AI. So the public and the engineers view of AI with artistic differences, where engineers see AI as a tool that cooperates with human in order to enhance human life. A lot of public sees AI as an entity that overpowers human. That's the negative way of looking into it. That's a one possibility, but should not faintly or vaguely adapted to it, because every technology has a merit as well as demerit. It's totally in our hands. So so AI is nothing but a tool in the human hand. So it's all about how we are going to use it. So machine learning is actually a discipline of computer science that uses computer algorithms and analytics to build predictive models that can solve business problems. So as per McKinsey and Co., machine learning is based on algorithms that can learn from data without relying on rule-based programming. So what does it mean? So algorithms are nothing but a few steps or a few paths which one need to follow, and that algorithm can be learned from the data. So data are nothing but any kind of data. It can be statistical or it can be digital or it can be any kind of info. Counting numbers is a data, and if you're taking up enough thousands of images of any nature, it's called as a data. So uh, any substance which we need to analyze, we can call it as a data. So without relying on rule-based programming. So rule-based programming is nothing but what we conventionally been doing for years and years. So for example, in previous session, I did Arduino programming, and that Arduino programming is a rules-based programming. And machine learning is based on the algorithms that can learn from data without relying on rule-based programming. I hope now you could understand it. So another definition which was given by Tom Mitchell is that a computer program is said to learn from experience E with respect to some of the class of task T and perform the measure P if it perform as a task T. So it is a bit confusing. I better snub it off. Let me continue because I don't have enough time. So machine learning is a subset of AI that deals with algorithms that learn from examples and previous experiences. So it involves identifying patterns in the data and utilizing them for future prediction. Now you could remember what type of AI which I have been used. So going back here, yeah, so theory of mind and self-aware robots are being achieved by only using the machine learning. And yes, in limited memory also a vague or an type of machine learning is being adapted. So in the next session, which I'll be going into much more depth in machine learning and deep learning, I'll be explaining how these systems work and how it is directly implied or implemented in artificial intelligence. Okay, now we need to understand how does a machine learning work. So machine learning accesses vast amount of data. It can be both structured or unstructured. I mean, structured and unstructured in the sense it is structured in the sense it can be well organized, well labeled, so that it could be much easier to understand the data. And it learns to predict the future. It learns from the data by using multiple algorithms and techniques. Below is a diagram that shows how mission learns from a data, and machine learning is a field of study that makes AI happen. So the easiest way to sum it up, all machine learning falls under AI umbrella. But artificial intelligence is much more than only machine learning. I think that sums up. So let's look into what deep learning is. Deep learning is a subfield of machine learning and quite similar to it, except that deep learning uses numerous layers of algorithms called as an artificial neural networks. So neural networks comes under the umbrella of deep learning, and deep learning comes under the umbrella of machine learning, and machine learning comes under the umbrella of artificial intelligence. Now you could have got an idea or an image like what are the steps being involved to create an artificial intelligence. So it mimics the brain's neural network, which has layered architecture. So deep learning involves using these layers to look for patterns in the data. And for example, Google's LeanNet model for image recognition is a deep learning application that counts 22 layers of network. So deep learning is a subset of machine learning that deals with algorithms inspired by the structure of our brain. And deep learning algorithms can work with an enormous amount of both structured and unstructured data. And the deep learning's core concept lies in artificial neural networks, which enables the machine to make decisions. So this is what a simple neural networks look like, and I have shown in the image. It can be not only two layers, it can be n number of hidden layers. It totally depends on how we are designing an deep learning model. So the network has an input layer that accepts the inputs from the data. The hidden layers is used to find any hidden features in the data, and the output layer that provides the expected output. Now let's think about what is the difference and what's the relationship between robots and AI. How could we differentiate both of them? So some people assume that robot technology and AI are one and same, while others think that AI is a subset of robotics or even vice versa. So it's easy to see why people get AI and robots mixed up. Hollywood and pop culture are probably to be blamed. So for past few decades, scriptwriters, novelists, I have had a heyday imagining humanoid robots with capability to learn, love, and even create. So such tales among almost always progress to a point where the mission surpasses the intelligence of their organic creators, which means humans. Sometimes they even go on to take over the world, and it ends with an epic battle between a human and a robot. So that is, of course, a merely fantasy at this point, because we humans are far cry from developing anything along those lines. And yet, new AI and robotics technology trends and developments are rapidly progressing. So these advancements incorporate both robotic process automation and artificial intelligence, now blurring the line between AI and robots in strange and wonderful ways. So as these technologies develop, the the distinctions between the two disciplines has become increasingly confusion. So this confusion has led to a rash of technologies and products being publicly mislabeled and further muddy the waters. For those of us who deals with AI technology every day, this trend can be quite irritating. So we at the FREA, we look the difference between robots and AI and show exactly what the key distinctions lies. If AI is a software, then robots are the hardware. A robot is a mechanical device that is capable of movement. It is designed to perform movement of function automatically, whether simple or it can be even a complex task. But without guidance, it is nothing it can do. In many cases, this guidance comes from the form of AI. An AI guided robot building a specific joint on a metal stand on its own is completing a specific task. A complex task would be involving a AI guided robot moving from point A to point B while scanning and assortment items in the floor and picking up and sorting those by weighs 2 or 3 ounces. In both instances, there is no thinking involved because robots does exactly what it designed to right from the beginning. So some robots operate off an external control device, which eliminates the need for AI altogether. In such cases, human handler takes the place of AI. But once AI is added to the equation, we get the robot autonomous capabilities. So when AI and robotics are combined, designers often create missions with animal-like or humanoid characteristics. So certain height, weight, size combinations are blandly practical, such as being tall enough to turn on light switches or smart enough to fit into the doorway, and etc. Plus, nature's design are tired and true. So, which is why many of our land mammals efficiently spot 4 legs instead of 10. So the future of AI is going to be very vast, and given the place of adoption and popularity of AI, it is headed towards future where automated transportation become more common. There will be an increased prevalence of smart cities where vehicles, phones, and home appliances will be run by AI, and everything will be smart. Human augmentation, where robots, as tech billionaire Tesla head Elon Musk put it, we would be able to do everything better than us. Robots will perform jobs that are potentially dangerous to human, and such as diffusing a bomb, defending in the line of action, lifting heavy objects, working in high-risk factories, or even handling hazardous substance. So as AI revolution continues to gather steam, we will witness disruptive technologies that will test the boundaries of our imagination. So this in this slide, I have mentioned about the current state of AI, which you could give a read. So I'll be moving on anyways. Let's look into AI predictions for the future in this year. So with this background, we may increasingly see new form of machine learning, one that can preserve and protect privacy. This is known as federated learning. ML could offer a way of different parties to learn this from the same data without compromising the privacy. So what does a term team predict in the next 12 months is that of the 8 predictions, I have listed few of it. Like some party will build an AI language model that runs 10 trillion parameters, or a big corporate AI lab shuts down due to changing strategy from its parent company. Even Chinese and European defense-focused AI startups will collectively raise 100 million in a year response to the US military activity. And even Facebook has a big breakthrough in augments and VR with 3D computer vision. So with a strong record, some of these predictions will certainly come true.